We usually think of AI memory as, well, basically a hard drive, right? Just a huge, simple list of facts. But what if it's something way more interesting? What if it's more like a living, breathing map? Today, we're diving into the hidden world of how AI models really remember things. It's a story about a battle between two different kinds of memory, and the surprising choice the AI always seems to make.
So let's just jump right in. When we tell an AI to learn something, what is actually going on under the hood? Is it just making a giant spreadsheet of facts? Or is it building something much, much deeper? A genuine model of the world it's trying to understand?
To get to the bottom of this, researchers gave an AI a really clever challenge. Just picture a subway map with one big central station and a ton of different lines branching out from it. The AI's job is pretty simple. It's given a starting point and a destination, and it has to figure out the path. It's a puzzle that's specifically designed to test how it learns and remembers a complex system like this. And hey, no surprise the AI gets really, really good at it. But here's the thing. To solve the puzzle, it can't just wing it. It has to actually memorize the map. And the way it decides to do that, well, that's where things get really fascinating. This brings us to the central conflict of our story. There are basically two competing ways an AI could store all this information. The best way to think about it is the phone book versus the GPS map. Both can get you where you're going, sure, but they work in totally different ways. So on one hand, you have what's called associative memory. That's our phone book. It's super simple. You look up station A, and it tells you it's connected to station B. That's it. It only knows its immediate neighbors. But on the other hand, you have geometric memory, our GPS map. This is a whole different beast. It's a rich, complex model that understands the relationships between all the points on the map, not just the ones right next to each other. Okay, let's pop the hood for just a second to get a bit more technical. That phone book memory is basically a simple grid called an adjacency matrix. It just puts a check mark next to direct connections. Easy. But the map is something called a low-rank factorization. Now, don't get bogged down by the name. The key thing here is that the structure isn't just a list, it captures global information. It inherently understands that station A might be closer to station C than it is to station Z, revealing the underlying geometry of the whole system. So this is it. This is our central mystery. The AI has two perfectly good options. It could take the easy route and just use the simple phone book, or it could do all the heavy lifting and build the complex map. Which one does it choose? And more importantly, why? And this is the part that totally stumped the researchers at first, because the AI consistently, almost stubbornly, prefers to build the complex geometric map. It does this even when the simple phone book of connections would have been totally fine to solve the task. So why do all that extra work? To figure this out, the researchers basically became detectives. They started by doing what any good investigator would. They rounded up the usual suspects and started ruling them out one by one. Okay, suspect number one. Maybe it's the task itself. I mean, it's a navigation puzzle, so it kind of makes sense, right? Maybe having to reason across multiple stops just forces the AI to build a map. It seems like a pretty solid theory. But nope. Turns out that's not it. The researchers tested this by giving the AI a much, much simpler task, basically just memorizing single connections one at a time. And guess what? This rich geometric map still emerged. So it's not the task that's forcing its hand. Suspect number one is cleared. All right, on to suspect number two. Maybe it's all about efficiency. There's a common idea that AI learning processes are, well, kind of lazy. They naturally prefer the most compressed or succinct way to store information. So is the map just a smaller file size than the phone book?
And again, the evidence says no. This quote from the paper is the key. When you actually measure the data storage required for both, the simple phone book memory is just as efficient, and sometimes it's even more efficient than the complex map. So the whole efficiency argument just doesn't hold up.
So with the most logical suspects ruled out, the answer had to be something deeper. It wasn't about the task. It wasn't about efficiency. The real reason the AI builds a map lies in this hidden fundamental force that's baked right into the learning process itself. And that force is called spectral bias. The easiest way to think about it is as an invisible hand that's guiding the AI while it's training. It's this natural, built-in tendency for the learning algorithm to not just memorize facts, but to actively hunt for and amplify the most fundamental patterns, the true underlying structure of the data it's looking at. And this chart right here is the smoking gun. What you're seeing is basically a window into the AI's memory as it learns. Those lines that shoot up and stay high, they represent the core geometric structure of that map. They start out weak, But over time, the learning process latches onto them and makes them stronger. And all the other, less important patterns, they just fade away. The AI's memory is literally self-organizing, snapping itself into a map.
This just gives us such a powerful final picture. On the left, that's the simple phone book memory the AI could have built. See how sparse it is? Just a few dots for direct connections. But on the right, that's what it actually built. That's the geometric map. It's not just a few ones and zeros, it's this rich, complex picture showing how everything relates to everything else. It didn't just learn a list, it built a world model.
So, why does any of this matter? This isn't just some quirky academic finding. Discovering that AIs have this natural built-in bias towards finding hidden geometry could fundamentally change how we build and understand them from the ground up. This geometric view forces us to rethink a lot. It could be the key to building AIs that have more robust world models. You know, the difference between an actor who just memorizes lines and one who truly understands the plot. It also helps explain this bizarre phenomenon where different AIs trained completely separately somehow develop the exact same internal maps of concepts. It's like they're both independently discovering the truest, most fundamental way to represent an idea. And if we can harness this bias, it could be a whole new way to train more capable and reliable AI. And that leaves us with one last, really mind-bending question. We've just seen an AI build a map of a pretty simple graph. So, when we train these huge models on the entire internet, on language and science and art, what other, far more complex hidden geometries is it discovering about our world? That's definitely something to think about.